Sum of a geometric series. A series usually means like the addition of a concept. So here's our formula. The sum of all the numbers is equal to the first term times the ratio to the power of the term number minus 1, and then all of that is divided by the ratio minus 1. Now that's for the series. The sequence, or geometric sequence, is also going to be important when we're missing some types of information. So the term number is equal to first term times the ratio to the power of the term number minus 1. We've got them all defined there. So here's our information they've given us, and they want us to find the sum of this series. So we got to find the sum of. The problem is they've given us this dot dot dot, meaning this is an unknown amount of values between it, and then we end here. So we know this is the first term, second, third, and then this is the nth term. We don't know what the n value is. And we can't actually use this formula to figure that out. We have to go back into the sequence, and we're going to use our sequence to figure out what our n value is. So that is the term value, that t at n. So we're going to have 1 over 243 over 243 is going to be equal to the a value, which is 27, times the common ratio, and the common ratio is to divide by a value of 3. Now, because we usually use everything's multiplication, we'll just say it's multiplying by a third. So we say multiply by a third. And then n is our unknown, and it's n subtract 1. Okay, so in order to work this out, we would move 27 to the other side. So when we move it to the other side, you'll have 1 over 243. And the quickest way to do this, instead of getting some decimal, you can actually just multiply 27 on the bottom of that fraction. So we'd be still working with fractions. And we have 1 over 3 to the power of n minus 1. Let's see what the denominator of that fraction will be. 243 times 27. 6561. Okay. So 1 over 6561 is equal to a third to the power of n minus 1. We need to isolate for the exponent, so we're going to use the log. We're going to take the log base 10 of both sides. When we do that, the exponent's going to drop down. So you have log of 1 over 6,561 is equal to the log of a third. And this exponent drops down. Think of it like it's going to be multiplied now, times n minus 1. Okay. So now that we've done that, it's going to be much easier to isolate for n. We're going to move the log of 1/3 to the other side. So we'll get log of 1 over 6561. And these are all values. You can plug them in and get whatever decimal you want. I'm just going to move them as actual equations, so it'll be very exact when we do it at the end. Divided by log base 10 of 1 over 3. Is equal to n minus 1. So we're going to get these values, and whatever they are, we're going to add 1 at the very end. So let's see if we can do it in our calculator here. We'll take log base 10 of 1 divided by 6561, bracket, and that's going to give us some value. And we're going to take log base 10 of 1 divided by 3. Okay. That gives us some value. And we're going to divide the two. So luckily this saves them, so that divided by that. And I could have written them in the calculator this way, it shouldn't make a difference. Equals approximately 8. It's probably the number 8. Okay, so we're going to say this is 8 equals n minus 1, and when we bring 1 over, we're going to obviously add it. So we get n is equal to 9. So that's just to find the value of n. So we now know that this is the 9th term. Now that we know this is the 9th term, we can use our series. So let's kind of go about on the side here, plugging in our series. The sum of the series is equal to a, which is 27, times our common ratio. Right there, blue, yeah. A third. Our n value is now 9. Subtract 1. And then all of that will be divided by our common ratio of 1/3 minus 1. They usually give you these answers as fractions. Is that right? So we'll try to actually equate this as a fraction. We'll go through it all as a fraction. So sum is equal to, we'll figure out what this value is. We're going to need a common denominator, which means we're going 3 to the power of 9. Okay, so 19,636. So that's what this fraction is going to be. So I have 27 times 1 over 19, 3, I think I read that wrong. 3, no, 8, 683. What was I saying? 683. 683. And since we have to subtract, we'll be subtracting by 19683. Subtract 19683. And then all of that is still above. We'll make that a common denominator too as a fraction. 1 over 3 minus 3 over 3. So we'll do 2 at the same time. We'll work around this. The sum of the series equals 27 times. When we subtract that, we're just going to have a negative value. So we're going to have negative 19,682 over 19,683. And all of that is divided by, what did they have? A third minus 2/3. So we're going to have negative 2 over 3. All these fractions can be confusing. We'll bring this in and then we'll do our fraction rules. So we got to do 27 times just the top value. So the sum of this, and the reason the book will work with answers is because as we start to round, we can get pretty off towards the end of this. So our 19,682, so 19,682 times 27, 531,414,5, and it's a negative, so we have negative 531,414. Is that right? Ooh, I can't believe I memorized it. 19683, and then all of that is divided by. So we have two fractions divided by each other. Negative 2 over 3. So it'll probably be easiest, and now we have some room over here. Think of it as writing it the way we would have in elementary school. So we have the two fractions beside each other. 531,414 divided by 19683. And when we divide fractions, so divided by negative 2 over 3, we can just invert and multiply, right? So we flip the second fraction and turn it into a multiplication question. So we're going to now multiply by negative 3 over 2, okay, and that'll equal, we know we'll get a positive value, and we're just going to put these two fractions beside each other. So 531,414 times 3 equals, ooh, these fractions are huge, 1,594, 594, 242, 242 divided by 19683 times 2, 39366, 39366, and this should give us some final value here. So we take these values and actually divide them. About 40.5. Yeah, so about 40.5 when you work it all out.
How does that make sense?
As a sum?
Yeah, because
this sum is constantly actually decreasing. So if we take a look, we started at 27, which is a relatively large number. Like we're already halfway there, right? To almost being, what does it say? It was 40. But because these values, as we go into the 9th term, all of these down here are very small values. So they're really not adding much every time we put them on.
Oh, okay. This is the sum.
Yeah, we're doing the entire sum.
Wait, how'd you figure out that was the 9th term?
I'll show you.